to transition, and it's my pleasure to introduce 𝗂𝘂𝘁𝗂𝗂𝗂𝗂, who is research engineer at the CAA list, and who is going to tell us about the ODD designer and the modeling of requirements. So 𝗂𝘂, over to you.
Yeah, thank you, Nicolas. So I will present you ODD designer, and I will come back to the definition of ODD, because we will come back to the ODD, and you are already having several presentation dealing with others, definitions, and so on. So ODD is the set of operational conditions under which the system must safely operate. So why we need a tool to design ODD is mainly to give more trust to our system, including AI systems or systems with embedded AI. And the idea here is to enhance the safety analysis and the safety validation of the behavior of the systems, to have more trust and to facilitate the adoption of the AI, and to integrate AI in the system of systems and complex systems. So what is ODD Designer? So ODD Designer is a tooling to define and specify ODD. Before building the tool, we have defined some requirements. So we would like that our tooling is domain agnostic. So that's why we do not specify our ODD using a domain-specific language. For example, for the automotive domain, or for the railways domain, or space domain, or whatever, we are specifying ODD for agnostic domain. So we would like that our DSL, our specific language, help us to design ODD, but without being specific to a domain, just like automotive or railways or space. So that's why we are using ontology to define our modeling language. So what we have specified is the ALDAS ontology, is the ontological language for dependability analysis system. So this work was introduced in a PhD thesis that was defended 2 years ago. So I put here some reference to have more details about this ontology. But what I would like to say here is that our language, our modeling language to define ODD is generic, is domain agnostic, and is based on ontology. And this ontology is also based on other upper ontology, just like UFO and so on. So this is the first metric. And also we would like to define our ODD with a language that is a machine readable language that we can parse, and that we can validate the occurrence and the semantic as well as the syntactic of our ODD. So the first tool that we have built in this same thesis was a POC to define the ODD from the ontology. So it is domain agnostic, that It was a first version of the tool, which is a web interface that the user can use to specify the ODD. So the ODD specification, it is like a web interface when the user will select some ODD attributes, and if he check this attribute, it is in the ODD, and if the user don't select this attribute, it's out of the ODD. So it was the first version of the tool, and of course the idea is to enhance the safety. So we will try also to generate the testing scenario and the hazard tables, for example, to do some safety analysis and hazard assessments. So this was the first version, but we realized that we need more powerful tool that that the user can use with some syntactic and semantic validation, and also to have a data that is well structured, and if we can use model-based system engineering tooling, it's really better. So since this, the ODD designer has been developed by a research laboratory in the CEA, which is expert in model-based system engineering design. So we have moved to the model-based system engineering. Model-based system engineering kind of engineering, and we have built the second version of the ODD designer input of into our the CEA tool, which is called 𝘂𝘱𝘁𝗶𝘂𝘁, to design a domain-specific modeling language. So this enhanced the first version, because now we can have two editors for our ODD. So we have a graphical editor and a textual editor, and we can, since we will inherit from those kind of model-based system tools, we have some specific syntax and semantic validation, and also some users that are more familiar with the graphical editor can also define their ODD using the graphical editor. So this was the second version of ODD designer. And also the third criteria, which is very important for us, is to be compliant with the standards. So there are the ISO 34503 that specifies the ODD taxonomy, and which was very inspired from the open ODD standards. So we have followed this standard, and which is standardized by the 𝗂𝘃 association. So the CEA is part of this association, and we are following the standardization steps for the open ODD language. So ODD designer is implementing the first version of the open ODD standard, because it was standardized last year, and we are working in the alignment with a second version of the open ODD. So we have built this tool called ODD Designer, and so what we should have in mind is it is a tooling that is based on the OLDAS ontology. So it's a domain agnostic tool. It offers two different editors, the textual and the graphical one. It was used in the Confiance AI project by two industrials, and we are working on the update on the new syntax of this language according to the Open ODD standard. We are validating also the coherence and the compliance against the standards rules using some solvers, for example, the SMT solvers, but we are also enhancing this functionality, the validation functionality, using more sophisticated solvers. We are also generating some open scenario test scenarios from the ODD. And we are also working on making this tooling open source in a way to be tested by the large community that are interested in this kind of tooling. So I will also present you a demo for this tooling. So if the first demo is ready, we can present. Yeah. So this is the kind. So the user can start by creating his project. So it is on top of the 𝘂𝘱𝘁𝗂𝘁𝗂 tooling, which is very similar to 𝘂𝗽𝗱𝘁𝗂𝘁, for example. So here we can see that in the palette, the user will manipulate toward operating feature, property, metric, state, which are generic concepts and are domain agnostic. And here we can see that we can also define our ODD using the textual editor, and here we have the auto completion to help the user specifying his ODD. But it is, as I said, compliant with the Open ODD standards. So we have the same taxonomy, environmental conditions, dynamic elements, scenery, and so on. But for the scenery, for example, we are domain agnostic, so we don't provide the roads, for example, for the automotive domains, because we can have systems that are airplanes or even space domain systems. So we are not as the ODD was defined by the for the automotive domains. The advantage of this tooling is its ability to be agnostic for the domains. So here we have also defined some libraries, for example, for the units, and we can, of course, produce a specific modeling language to a specific domain if the user is interested in one domain than another. So here it is just an example where we are specifying the illuminance property, which is a kind of a visibility in the visibility features. And now we will specify the metrics and the type of this property and the units. For example, the units will be a lux here. And of course, we can specify the constraints on the values of this kind of properties. And this is by the mean of state. For example, we will define the daytime state, which is the interval when the luminance is between 1 and 2 thousandths, for example. So it is just an example. We can move to the second video to just yes, to the second video for the validation of the coherence between the different constraints that are specified in this kind of ODD. For example, here the user has specified two different constraints that are not coherent, so we can validate this kind of ODD. So the idea is to generate a SMT file. So for audience that are familiar with this kind of solver, which is open source, completely open source. It is just a poke to prove that we can validate the coherence between the different conditions that we can specify in our ODD. So here we will correct and we will validate the ODD again, and the tool will say that okay, now we didn't have any problems. So validate the ODD file. So it said that so this idea is to validate the ODD before generating the testing scenario, and by this way we are sure that the scenarios that we are that the ODD is valid against some constraints that we can define before the validation, and also that the testing scenarios are in the scope of the ODD and are not and not outside the ODD. This is a presentation. So this is the first presentation of the tooling, and yes, for the perspectives, we have a lot of perspectives from the research point of view. So what I have presented is just for the implementation point of view, but we are also working on the research part of view for the specification of the ODD and the formal verification of the ODD, and the link between the ODD and the product line engineering, and a lot of research problems. So we are open to any kinds of collaborations in this field. Thank you very much.
Thank you very much, Asma, for the presentation and for the demo.